Yes, class. Good evening. Am I audible to all of you?
Good evening, ma'am. Yes, ma'am.
So all have joined. Jania, Mohammed, Tarif. Yes, Tarif, where were you? I think you were not
No, miss.
attending the classes.
Yeah, miss. I had exams. Now it's over.
Okay, they are over. So how was your exam?
Yeah, miss. Good.
Okay. So physics also was over, no? By now is also
Yes,
over.
miss.
Okay. Abdullah, Tareem. Talha. Okay. C class. We had completed with collision. That was a part of work, energy, and power. Now we have chapter number 7, that is rotational motion to start with. So all those students who are having any difficulty from the previous lessons or who have joined earlier in the middle between the work, energy, and power lesson. So now you'll not be having difficulties because this is a fresh chapter. And now since we have already covered the rest of the portions of circular motion already under laws of motion, so this is not a very lengthy chapter for us now. Otherwise, this had included a lot of topics that we have already covered. Now, see, you have various concepts over here, like center of mass will be one of the good concepts that is important. Let me just brief you with what is the lesson. Then you can note it down. And as I have already said, the backups will be continuing along the weekends, during the weekends time. The way I think only Tareem had the class of differentiation and integration, we had it. Now from next Friday, on this next Friday only, we'll have a class starting from motion in a straight line. So the timings and everything I'll tell you when we'll have the class on Wednesday. Right now, let's start with the lesson. The lesson is your motion of system of particles and rotational motion. So, chapter number 7 of your NCERT. Now, see why we had this separate chapter. If I had already discussed circular motion with you in case of laws of motion, so there wasn't any need of this lesson to be separate. We could have completed it as a single topic only. Why we did circular motion earlier? The reason is that all the lessons, so till now, what we have done, motion in a straight line, motion in a plane, laws of motion, work, energy, and power, all these chapters are just valid for point masses. What if you do not have a point mass? If you have a point mass, let's say this is just a point mass. So all the lessons were valid for this point mass only. For example, now somehow you get a rigid body. So how many points will you answer? This was a single point mass. Now I have given you a body. Let's say this is a rigid body. Then how many point masses will be there? One here, one here, one here, one here. Will you be even able to count it? Definitely not. This will be infinite. So when infinite point masses are there, it makes it a rigid body. Now what will be the motion, rotational physics and everything? Not just rotational motion, even the motion of this system of particles. This now becomes a rigid body. So everything that we had studied till now was applicable for point mass. Now there's a need for various point masses, or if 2 point masses I choose, let's say this point mass and this point mass. There's a separation between these 2 point masses, right? There is a definite shape of this body. There's a definite size of this body, certain volume of this body. That makes it a rigid body. Rigid body is what? That has a definite shape and size. If I talk about the pen that you all are holding while writing, that's a rigid body. It's incompressible. You're not able to compress it. It's rigid because it is having definite shape and size. Now, during motion, what happens? This separation does not change. The entire body is in motion, but the various points or the particles that are present, that do not change in case of rigid body. That can change in other vapor and liquid states, but for solids and rigids body, you do not have it. We have a separate chapter, mechanical properties of solids. There we'll see all these properties in detail when we'll do solids and fluids. But right now, just understand that's why we had motion of system of particles. It means this was a particle when we were studying this earlier. This was a particle point mass. Now this makes it a system of particles. It means not talking about a single mass, various point masses. So firstly, let's talk about rigid body. So first thing, body having definite shape and size. This is the basic thing. Body having definite shape and size. Also, during the motion, separation between any 2 points, let's say this point, separation between any 2 points does not change. The separation does not change. Any 2 points you take. So, during motion means when the body is moving, when the body is in motion, that time. So, during motion, separation between 2 points on a rigid body does not change. All right. So now for a rigid body that is having a definite shape and size, and whenever the body is in motion, any 2 points if you take, the position does not change within the 2 points. For example, I'll show you it clearly. Let's say this is a rigid body. Now here I have taken a point A, I have taken this point B. So now this separation, let's say whatever is the separation, 5 centimeters, take any separation between them. This does not change. This remains fixed, this separation. Now, why is this point important? Why am I not emphasizing on any other point that is present? Because this point is necessary for the motion, and this is the reference point that we'll be using. Now, system of particles is what? This system of particles, motion of system of particles, I have written. The system of particles is this only. Point masses we have studied for everything. Velocity of a point mass. We were not actually studying point mass directly, but references and the formulas and everything was valid for point mass. We didn't talk about all the points that were present. Let's say a car is moving with certain velocity. We didn't talk about all the point masses that is present in a single car. No, we took the whole car, entire car as a point mass, right? Now we are studying about if this is the system of particles, now what is going to be the motion? So what is meant by the system of particles? So system of particle means system having more than one point mass. System having more than one point mass. More than one point masses. Right? So understand, it can be discrete, also it can be continuous. In the sense, just remember that these are just basic points. Nobody is going to ask you in your examination. These are just for your understanding. Before we start with the actual center of mass, you should have an idea what are you going to study in this lesson. It can be discrete in the sense, if I say I have M1 mass here, I have M1 mass 2 over here, I have M1 mass 3 over here. At certain point, 3 point masses I have, which are not continuously placed with each other. They are at certain distances scattered. Then also I'll say this is a system of particles because it is comprising of more than a single particle. Or it can be continuous. Continuous means like a rigid body. Let's say this is a rigid body. So all the point masses that will be present here, all the point masses that will be present here, all the point masses that will be present here. These are what? These are continuously placed beside each other. That's why, no, these are so close to each other that we directly see a complete entire rigid body like this. The gapping and the segregations between the particle we are not able to observe. So even you will call this system as well as a system of particle, as well as this system as system of particles. Now, one thing more, what you have in this lesson, see, types of motion. This is now, as I've told, not a very big lesson. Rest of the students will complete this in the backup circular motion, what we have done. But as per now, we have already covered many portion of circular motion. So most of the students were there also, some of you were not there. So that's why this is not a very big lesson. That's also I'm saying, so that you can now revise it. So types of motion in rigid body. If you have a rigid body, first motion that is possible is a translational motion. Translational motion. Translational motion means body is moving forward, back and forth, anteriorly, posteriorly, like this. Then you have rotational, where there is axis, rotation occurs. Everything of translational motion gets changed into the analog of rotational motion. And then we combine translation plus rotation. This is all what we have to study. And what do we call this? We call this as rolling. See, translation you can understand like this. You are just pushing a pen. You have kept up the pen on your notebook and now you are pushing the pen. That is translation motion. The body is moving forward. A displacement has been covered. Right? That is known as translation motion. Rotation means the way the fan moves. That is the best example of rotation motion. What happens? The fan is fixed, pivoted on an axis, and the blades move. That is rotational motion. Translational plus rotation. You can take the example tires. When the tires roll on the ground, what happens? Rotation also occurs as well as forward displacement also occurs. That is known as rolling. So these things we have to study. For translation motion, we'll study a new concept. Rest of the things for translation motion we have studied already, right? For rest of the things for translation motion, that is velocity, acceleration, displacement, distance, all these things we have been studying it. Those are valid for it. Now, what new concept is here in translation motion now is center of mass. So center of mass, let's discuss it. But before you note down these introductory points, then we'll start with center of mass. And class, center of mass is a very important topic. Very important topic is your center of mass. Students who are preparing from their entrance perspective as well, CBSE, not just CBSE or these exams, board exam, but as well they are preparing for JEE, NEET or any exams. Center of mass is very important topic for you as well. All right, note this down, note all these introductory points, then we'll do center of mass. Okay, now starting with this topic, center of mass. So this is a big topic in comparison to the other topics that we have. Now, center of mass is what? See, if there is a body, let's say this is a body that we have. So as we have discussed, there will be so many point masses that will make up this body. No, these point masses will be so close to each other that this will appear as a rigid body to us. So many point masses are there. Now, how will you estimate the mass of all of it? How will you estimate the distance traveled by each? How will you estimate the velocity of each particle? Because if we are considering about the system of particles, then we have to have all these points. Now, see, this is impossible. Why? Because infinite points are there. You don't even know the number of points that are present. So how will you be able to calculate the velocity, acceleration, displacement, and all the physical quantities of each? Definitely not. You cannot calculate it. So what we do, we assume a point where we choose a point or assume a point where we think the whole mass is supposed to be concentrated. And that point to where we think, where we feel, where we suppose that the entire mass of the body is concentrated, that point is known as, let's say this is the point. So this point is known as center of mass. So center of mass is what? Point at which the entire mass of the system is supposed to be concentrated. Now, this line actually means what? That point at which the entire mass of this body is supposed to be concentrated. What is the physical meaning of this? This is just a definition term. What is actual meaning of this? See, meaning of this is basically that instead, if I use this rigid body, whatever phenomena and properties this rigid body exhibit, even I replace it with this point mass, no, that is the center of mass. This is the center of mass. So even if I replace it with the center of mass, there won't be any effect of it. It means we can replace the entire body with this center of mass. Now, for center of mass, for point masses, we can calculate things. For all these points, it was difficult. No, for this particular point, we can calculate. So that's why we say this is the point at which this is the point at which entire mass of the system is supposed to be concentrated. And even it's not just for a rigid rectangular body also. Even if you have a disk, center of mass will be present for a disk. Any example you take. Also, it's not necessary that you are taking the center of mass here only. It can happen that the point may lie outside. It could have happened, no, that in this also it might have lied outside. So it's not necessary that you think that center of mass always lies within the body. The center of mass can lie outside also. Because why? Because this is not the center point of the body. This is not necessarily coinciding with the geometrical center. Understood? Since I have taken a disk, I have taken this rectangle sheet, it does not mean that this will always be at the center. It can be at the edge. It can be outside as well. Can even lie outside the system. It can even lie outside the system. And we just remember we use it for translational motion. We'll see different concept for rotational motion. But right now, remember, we are only studying this for translational motion. Now, how to calculate the center of mass of a system? That is more important. No, this was just the meaning of it. Now, how do you actually calculate the center of mass of any system? So let's do plot it graphically so that this is y-axis, this is x-axis, this is the origin. Let's say some M1 mass we have taken. This is the M1 mass. Here M1 mass is there. Let's say from the origin, the separation of this M1 masses are. Likewise, we'll be taking some M2 as well. M2 will be there, separation will be R2. M3 will be there, separation will be R3. M4 will be there, separation will be R4. Let's say n number of point masses are there, Mn. So Rn will be the separation. This I have taken so that n number of particles are there. N number of particles are there because we cannot count the particles. So, and we are not even aware of how many particles are present in a single rigid body. Now, how to calculate their center of mass? These are all the masses. Till now, I have not taken the center of mass. Let's say now I am taking at this particular point here. Let's say here. This is the center of mass of the body, this point. And let's take the separation as capital R from the origin. This we are calculating. We are not concerned with all these masses, rest of the masses. Why? Because they are infinite. We cannot talk about each of these masses. We cannot talk about each of these. We have to talk about the direct center of mass of the system. So R are what? These are R1, R2, up till this Rn. These are just position vectors. Position vectors means separation from the origin. Now formula for any point to calculation for the center of mass. If this R is the center of mass, formula C, M1 multiplied by the separation from the origin or the axis, R1, plus M2 into R2, plus M3 into R3, plus M4 into R4 up till Mn into Rn, nth number, divided by the total mass of the system that is present, M1 plus M2 plus up till Mn. This is the formula of center of mass. This is how you calculate it. So let's say somewhere if we are calculating it, you require the x-coordinate of the center of mass. So for x-coordinate, you will simply xcm will become, that is x-coordinate will be m1 into x1, means the point that is lying on the x-axis, like this becomes your x1. Fine, so m1 into x1 plus m2 into x2 up till mn into xn divided by again the total mass, mn plus m2 plus m3 plus mn, like this. Similarly, for YCM as well, M1 into Y1, that is within the Y-axis, this point within the Y-axis. M2, Y2, up till Mn, Yn. Y is what? The Y coordinate, whatever is the separation, divided by the total mass. Even for X coordinate done, Y coordinate done, even for Z axis, you want to find it out. So ZCM will become M1 into Z1 plus M2 into Z2 up till Mn into Zn divided by the total mass of the system. This is the formula for calculation of it. Understood? Let's take a question. Let's do it with the help of a question. Then I think it will become clear how to use it. See, how do we use this formula? I'll give you a triangle is there. Let's place it to the origin. So again, y-axis, x-axis, this is there. So 3 point masses are there. All right. This point mass is 1 kg. Here you have point mass 2 kg. Here you have the third point mass 3 kg. All right. These are placed on the vertices of a triangle of each side A. So if all the sides are A, what type of triangle is this? If all the sides are A. Yes, Tereem?
Equilateral triangle.
Equilateral triangle. Yes, this is an equilateral triangle. Now you have to find the position of center of mass. Calculate position of center of mass. Now see how do we calculate it. We'll use the same formula only for the calculation of it. We'll use this only. XCM, YCM we'll calculate. Z-axis is not required because this is just kept in XY plane. This entire is the XY plane. So Z-axis is not required. We'll calculate for center of mass. We'll calculate XCM as well as YCM. Now let's start with XCM first. Fine, let's start with XCM. So formula we did. So three masses are there. So M1 X1 plus M2 X2 plus M3 X3 divided by M1 plus M2 plus M3. Now M1 is 1 kg. M1 is 1 kg. What is X1? This, what is X1? See, this is exactly kept on the origin. So x-axis coordinate for 1 kg is 0 directly. So M1, X1 will be 0. Class, this is a very basic example I have taken. This question has come in most of the schools half yearly also. So pay attention to this, and any doubts you have in between, let me know what is the query that you have. I'll repeat it because this is a basic question and it is important how to do this, how to solve this. So M1, X1. Now M2. M2 is this 2 kg. Now see X2. Point mass 2, that is 2 kg is kept on x-axis from the separation from the origin at what distance? That is A. So it means X2 will become A. Now talking about X3. Right. Now talking about X3. So see here. This is M3 will be what? M3 will be 3 kgs. Fine, 3 kg. Now this is kept where? This has no specific point, right? This is X3. Understood? This part is X3, no? Rest of the things were given. X2 was this. X2 was given. X1 was exactly at 0. So X1, X2 we have got. What about X3? How will we write it? See, this is exactly on the longitudinal altitude of the equilateral triangle. And this always bisects the base. It means this part will become A by 2. This part will become A by 2. So X3 is A by 2. Now we have everything for calculation of XCM. So XCM will be what? See, all these things we have. So XCM will become 1 into 0. 1 into 0, that is M1 X1 plus M2 X2, that is 2 into A plus M3 X3, that is 2 into A by 2 divided by the total mass, that is 1 plus 2 plus 3. So this becomes 7A by, this is 7A by, this is 6 into 2, that is 12. So 7A by 12. This is XCM. So we have found the coordinate. One of the coordinates we have calculated. Understood? Now coming to YCM. YCM we have to calculate. So similarly, Y1, X1, everything we have to calculate. See, M1 will be 1 kg. Now Y1 we have to tell. So see, Y coordinate for the 1 kg point, that is this 1 kg. X coordinate is also 0, Y coordinate is also 0. Right, or look in the triangle. Let's find out all the coordinates, then I think it will become helpful for you to solve. Look here, look at this triangle. Just look at this triangle, right? X1 has the coordinates 0, 0, right? It is on the origin. So X1, this X1 is 0, Y1 is 0. Coming to this point, here X coordinate is A, Y coordinate is 0. So A, 0. This becomes X2, this becomes Y2, right? Because this point mass is exactly on the axis and there is no coordinate of Y-axis. So Y is 0, but X-axis has the coordinate that is A. Coming to this point, X value was A by 2, comma. Now Y is what? Y we have to find out. So how can we find out y? Y3 is this separation, right? This is y3, no? This entire, this is y3. So C class, if you look, this forms a right angle triangle. This is A by 2. Just give me a second. This is A by 2. So that means if that is A and it is A by 2, so that makes it, if you use the identity, that makes it 3A by 2. Just a second, I have to plug in my laptop. Just give me a minute. Yes, so this becomes what? If this is A by 2, and you use your Pythagoras theorem, so this side will become what? Root 3A by 2. So this becomes root 3A by 2. It means A by 2 is x3, the way we had A by 2 is x3, and this is y3. So whenever you are calculating or doing or solving any question for center of mass, find out all the coordinates that are present. So y1 is 0. Then m2 is 2 kg. Y2 is again 0. M3 is 3 kg. Y3 is root 3A by 2. Fine, now you just have to put it into the formula. YCM will become what? YCM will be M1 Y1 plus M2 Y2 plus M3 Y3 by M1 plus M2 plus M3. This you do and let me know what is YCM that you're getting. Note it from here. Any queries you have, let me know. Okay, this is YCM that you're getting. 3 to the power 3. What is it? 9 it will become, no then? 9a by 12. Okay, that is root. Okay. 3 root 3a by 12. Okay, so Waziha is getting 3 root 3a by 12. Others also confirm. So only Waziha has tried it. Okay, note it down, and rest of you also try YCM. One answer I have already got from Waziha. Okay, you are also getting same root 3a by 4. That is 3 root 3a by 12 only. Okay, so that will be the answer. Waziha and Terim both have got root 3a by 4. 7a by 12. See, this is 2a. Here you have, okay, it will be square also. No? One more a we have. 2a, this is 0. So 2a plus we have 3a by 2. Fine. So see, when you take the LCM of this becomes 4. So 4a plus 3a by 2, that makes it 7a by 2. And 3 plus 2 plus 1 is 5 plus 1, 6. So 7a by 2 into 1 by 6, that is 7a by 12. Understood how this is 7a by 12? Also, class, some points that will help in your calculations. If you have two masses, no, M1 mass is there, M2 mass is there, they are separated by certain distance A, and you have to find out where the center of mass will lie. So if, let's say, masses are equal, let's take the first case as masses are equal. Let's say both are having the mass M. If such is the case, no, in your calculations, always remember that it will lie at the center then. Center of mass will lie at the center for equal masses, if this is the case. And if unequal mass is there, then what? If, let's say, this is M1, this is M2, separation is A, M1 is greater than M2, this is a heavier object, then see, center of mass will lie somewhere here. It will lie near heavier mass. So these points will help in your calculation and they can be asked also. So like center of Earth, Moon system, the center of my mass of the system will lie closer to Earth because mass of Earth is greater in comparison to Moon. Okay, now second thing, from center of mass calculation only, if you do not have uniform mass given, or let's say you do not have a definite mass. Right now you knew that the mass was 1 kg, 2 kg, 3 kg, you were sure about it, so you use the formula. If you are not sure about it, you have variable quantities. For variable quantities, we always integrate. So this will become integration of x dm divided by total mass. Or if you do not have total mass, then you will integrate the total mass to integrate dm to get total mass. Similarly, ycm, this will become ydm. Dm means what? Where you are integrating y. Ym, that is y dm by integral of dm. Same thing for zcm as well. Z dm by m is equal to integral of z dm by integral of dm. Now let's take the example of a question. Let's take a question where this integration is involved. Let's take example of a rod. This is a common question that comes in the exams. So length of the entire rod is L and mass is M. Fine, rod's length is L. Mass is M. And a very small section has been taken, that is dm, whose length is dx. Entire was m, but if you take a very small section, when you place this d, this makes it what? Infinitesimally small. Means this dm will be something like 0.0000000 something, then 1 kg, such small value. So length will obviously be small. This will be the length for this much, and this will be the mass. So dm is the length we are taking, and dm is the mass we are taking. So this comes as a derivation also. So you'll start with properly. Consider a small element of mass dm and length dx at a separation of x from origin. So this is the origin I have taken. This is origin. And this is L, length L. This is length L and this is origin. So this separation I have taken it as x. Whatever here you will take, no, dx, dy, dz. Take x, y, z here as well. Now, what did the formula was? What was the formula that I had written just now? It was x will be equal to x dm by total mass. Now, from where are we integrating this x? From 0 to L, no? We want to find out the center of mass for the entire length, right? For the entire length, we have to find out. So, xcm will be what? We just have to integrate this. It means take 1 by m out. Integrate x dm from 0 to L. Now tell me, can we actually integrate x and dm together? This is not m that we can integrate. M dm, if it was, then we could have integrated it. You cannot integrate this, no, x dm. How will you integrate it? You cannot write it as x square. You integrate when this is the function. It means both are same. But here you are getting something different. It means we have to have a little different value. Either we have to change dm or we have to change x. X we have taken on our wish, we cannot change. But let's find out dm. See, class, tell me one thing. Mass of the entire rod of length L, mass of length L is m. So what will be mass of unit length? Unit length means 1. 1 unit, 1 centimeter, 1 meter, anything. L, lengthened mass, lengthened rod had mass m. So 1 unit will be, what will be the mass? Unitary method, class. Mass of L length is m. So 1 unit length will be what? If I say cost of 5 chocolates is 10 rupees. So cost of unit chocolate, that is 1 chocolate, will be what? No, not 1 meter or centimeter conversion. Simple in terms of L and M. See, take it.
It would be M by L.
M by L. Yes, perfect, Terry. If I say you have 10 chocolates, you have 5 chocolates whose price is 10. Let's say 10 rupees is the price. So cost of unit chocolate, that is 1 chocolate, will be what? Whatever is the number that you're having, you'll divide it, right? So that will be 10 divided by 5. 10 rupees was the amount for 5 chocolates. For a single chocolate, it will be 10 divided by 5, that you will get 2. 2 is the cost for a single one. Similarly, length L is having mass m. So unit length will be m by L, as rightly answered by Terim. So if this is for 1 unit, right? So it means 1, like the example I was referring. So cost of 1 chocolate is now 2 rupees. So cost of 2 chocolates will be what? 2 into 1, that is that 2 into 2, right? So cost of 3 chocolates will be what? 3 into 2. Cost of 4 chocolates will be what? 4 into 2. Similarly, cost of unit length is m by mass of unit length is m by L. 2 unit length will be 2 into m by L. 3 unit length will be 3m by L. If I say dx length, which I want to calculate, so that will become what? M by L into dx. So this is what? This is the mass of unit length. And what was the mass of unit length? Mass of unit length was dm only, no? Mass of unit length, that is dx. Mass of dx was dm, right? Mass of L was m. Mass of dx is dm. So this is what is the value of dm. Now put it in the above equation. Instead of dm, write this entire term. that is xcm, which was integral of x dm from 0 to L, 1 by m was there. Here now keep in the values of dm. So 0 to L, instead of dm, I'll write m by L into dx. M by L are again constant, so that makes it m by ml. Now I am left with dx integral of this. Understood? This is how we have obtained it. Now this is simple integration that is left. See, 1 by L will be here. We have studied integration. On Friday only I had taken the class. X to the power n is there. Here x to the power 1 is there. Add 1, n plus 1. So we have added 1 plus 1. Whatever is this term, put it in the denominator. So we have put the term in the denominator and keep the powers 0 to L and 1 more. This 1 by L will also be there. So what are we left with? Those who are weak with integration, let me know. I had already taken the class, extra class also. 1 by L, this makes it x square by 2 from 0 to L. Now what did we study? This 2 also will come out here because this is constant. Upper limit in the place of x minus lower limit in the place of x. So that gives L square divided by 2L. That makes your answer as L by 2. So this is the final answer, L by 2. First tell me, is this clear to everyone? This question, this is very important question. And these types of question do come. This is not a very advanced question that I have discussed. This is a part of your syllabus only. Clear or not? Okay, to Waziha, is it clear? What about others? Jania, did you understand? Tarif, Abdullah. What about you, Abdullah? Understood?
Yes, ma'am.
Talha, did you get it? Talha, this question?
Yes, ma'am.
Okay. Okay, one more thing, class. One more thing. Then you all can note all these things. By chance, so in your numericals, if you get a system no, which is symmetrical, regular shape if you have, regular shape, regular or symmetrical shapes, that will make your questions very easy. Always remember, for regular and symmetrical shapes, like let's talk about circle. It's a regular shape. Let's talk about a square. It's a regular shape. Anything. Let's talk about rectangle. So for regular shapes, make it as a note point and write it. Center of mass lies with the geometrical center. This will become the center of mass here. Exactly at the center will be the center of mass. Here will be the center of mass. It means if this entire length is L, so this will become L by 2. This is the case. This will help in your numericals. All right, note it down. Any doubts you have till now, let me know. Because we are on the beginning only of this lesson. Otherwise, then we'll have to move towards forces of center of mass, acceleration of center of mass. All these things will also be calculated. Let's do some numericals only. Rest of the things I'll start from the next class. Right now, let's do some numericals based on center of mass. Second question, no? That was the first one. Second. See, from a disk of radius r, the disk has the radius r. From a disk of radius r and mass m. See, a circular portion has been removed. Of r by 2 radius has been removed. Calculate center of mass of the remaining disk. So it means this was an entire complete solid disk of radius r and mass was m. This r by 2 radius part was cut, and now this crescent shape is left. And whatever the shape is that we have to calculate now the center of mass. Earlier the center of mass was here. Now we have to find out center of mass. So see, if I find out for the remaining part, no, this is the remaining part, right? This part. This part is now remaining, no? This has been cut. So for remaining part, if I take the entire disk, original disk that was present, center of mass of original disk, and I subtract the disk, this disk that has been formed, that has been cut, then I'll get the remaining part, right? Disk of r by 2 radius. If original disk of r radius and I subtract this, then only I'll get this part that is left. This part that is there. Now I'll get it. So see, the removing, no, x removing. Let's say x when we have to find out center of mass of the remaining part. This will be m1x1. That is for the original disk. Minus m2x2 by m1 plus m2. This formula you will use now. These types of questions are there in your syllabus. So pay attention to this question. But see, m1, you know, m1 is the original disk. This is the original disk, no? You're talking about the original disk. So m1's, that is the original disk mass is m1. x1 we also know, that is the center of it. Right, see, I'm taking the origin here. This is the origin that I'm taking. So this will be 0. This will be 0, 0. So this is 0. I'm taking this as the reference axis. Right? We have to have some origin. So it means x1 will be 0. M2. Do we know what is the mass of the disk? We don't know what is the mass of the smaller disk that has been cut. Whose radius is r by 2. We do not know this. So firstly, before finding out the radius of center of mass, we have to find out this unknown m2. Then only we'll be able to insert it. So see, how will you calculate m2? Again, unitary method. See, mass of complete pi r square was m. So mass of unit area will be what? Same thing, m by pi r square. So mass of r by 2 area. So mass of pi r by 2 square will become m pi r square into pi r square by 4. So pi will cancel. right? Pi r square gets cancelled. So m2 comes out to be m by 4. So m2 will become m by 4. Now you all can put in this formula and get the answer. Fine. Note this down. All those who have completed, you all can leave now. We'll continue with this on Wednesday now. Center of mass, entire topic we'll complete on Wednesday.
Thank you, ma'am.